Atoms are tiny particles which make up our universe. Inside the center of an atom lies a nucleus. This consists of protons, positively charged particles, and neutrons, which have no charge, and is surrounded by a cloud of tiny, negatively charged particles called electrons. All matter consisting of these atoms is to some extent radioactive.
Discovered by Henry Becquerel, radioactivity occurs when particles are emitted from a nucleus as a result of nuclear instability. These high-energy particles can be captured and used as fuel to create electricity that power our cities and homes. As a nucleus decays, it releases an alpha, beta, or gamma particle, and this process is known as transmutation, which means that an element such as uranium-235 will change into a new element as a result of losing these particles. Alpha decay occurs when a particle consisting of 2 protons and 2 neutrons is ejected from the nucleus, and as a result, the atomic number decreases by 2 and the atomic mass decreases by 4. Beta decay occurs when an electron is emitted from the nucleus, and when this occurs, the atomic number increases by 1 and the mass remains the same. Gamma decay occurs when a nucleus changes from a higher energy state to a lower energy state through the emission of photon radiation. This type of radiation has virtually no mass and does not affect the atomic mass or number.
Fission is the process by which atoms are bombarded by particles that causes them to split and release energy and more particles. This process is utilized in nuclear reactors. In the reactor, heavily radioactive, high-energy atoms such as the isotope uranium-235 are bombarded by neutron particles, which then cause them to split and release more neutrons that will likely hit other uranium atoms. This continues the chain reaction and allows us to capture its energy. The energy released by the atoms is mostly heat energy, or infrared. This is then used to heat up water and evaporate it into steam. From there, the high-pressure steam is pushed through a turbine, which drives a generator, creating electricity. After the steam is spent, it is then condensed via condenser tubes, and the leftover water is reused. After a uranium-235 atom is split and the energy is spent, 2 highly radioactive elements remain. These 2 radioactive elements are barium-141 and krypton-92. These isotopes have extremely long half-lives, which means that they require thousands of years to decay and become non-radioactive.
Fusion is the process in which 2 small atomic nuclei fuse together and form a larger single nucleus and release energy. This reaction is proven more effective than fission by Einstein's famous equation E equals mc squared. Nuclear fusion is the process that occurs in stars, like our Sun. It begins when protons are compressed and heated, causing them to combine and form a deuterium particle, and from there, combines with a proton to form helium-3 particles, and these particles then combine and form helium atoms and free protons. This process releases more energy per atom than fission and has no harmful byproducts. This process is repeated with heavier and larger atoms, forming new elements and energy. This is how all elements in our universe formed and continue to be made. Why aren't we using it? Despite recent technological advancements, humans do not have the capability to harness such immense power. The process of nuclear fusion requires incredible pressure and heat that cannot be created on Earth by artificial processes. Currently, no man-made object is strong enough to withstand the forces at play.
Nuclear fission is becoming increasingly popular around the world. It releases no carbon dioxide or airborne pollutants and requires little fuel for overall energy produced. Along with its benefits towards society, fission can cause massive destruction when used in warfare or during natural disasters. Invented in 1945, Fat Man and Little Boy were 2 devastating atomic bombs that utilized the power of nuclear fission to devastate Hiroshima and Nagasaki.
Although this process is not yet harnessed by humans, fusion would offer an environmentally friendly source of energy that produces significantly more energy than fission without the radioactive byproducts. We have yet to see the true potential of nuclear fusion, but the possibilities are endless, especially in regard to the alternative energy crisis we appear to be approaching.
Nuclear fission and fusion are 2 of the most fascinating and important facets of chemistry and continue to be applied and studied by scientists all over the world.
Thanks to the work of people like Henry Becquerel and Albert Einstein, the power of the atom can be utilized for the advancement of technology and society, and hopefully never for the use of mass destruction.